this is the Arduino-based digital optical communication system featuring the dynamic adaptive threshold technology. Here are a few of the other students who also worked on this. So this is the setup. So all this is in addition to this, you would have two laptops, which is kind of cheating. One of them plugged into the transmitter, one of them plugged into the receiver. Now all the laptops do is a power source and a display, and also a keyboard for the transmitter. So you type in a message, the transmitter takes it, and using a laser diode, it will blink that message through this tube that is filled with mineral oil, and the receiver will receive the message using this photosystem. If none of you, whoever doesn't know what a laser diode and a photosystem look like, this is a little close-up of them. Here are, for the vinyl tube that's filled with mineral oil, here I have a little diagram of several different, the index of refraction of several different materials. The only reason that we use mineral oil instead of just water is, well, mineral oil isn't conductive, so we can safely put the laser diode photoresistor into the mineral oil without having to worry about short circuits. Now, as you notice here, the index of refraction of the vinyl is higher than the mineral oil, which means that the light will tend to stay in the vinyl rather than the mineral oil, which isn't ideal, but enough light stays in the mineral oil that it works. Here's a little diagram of our transmitter. You really wouldn't need a breadboard for this, but we have one in the diagram anyway. And all this really is a setup to blink an LED on and off. Instead of an LED, we have a laser diode. All the magic's done in the program. Here's a diagram of our receiving Arduino. And what this does is it's measuring the change in the voltage on the photoresistor. And using this, it's reading the change in the voltage and feeding it to analog pin A0. And in the program, when you first are starting this up, it will measure the kind of ambient light level and calculate a certain threshold for the light to be, so that if it measures anything above the threshold that it measures to be the ambient light, it will detect that as a pulse from the transmitter. So it's not a good idea to be flicking the lights on and off while this thing is running. Here's a little diagram of the character packets. So right when you are sending a character with the transmitter, here you have an example with the ASCII character of 5. So you type in the number 5 onto the transmitter, and the transmitting Arduino will convert the 5 into the binary, the 7-bit binary packet here. And so the receiver knows that that a character is about to come. It will send signals, which is just a flash of light that tells the receiver a character is on its way. And then for the first 20th second, the laser diode on the transmitter will be off because it's a 0 as in the binary. For the next 20th of a second, the laser diode will be on because it's a 1. On, off, and then on again. Now if that 5 was in the middle of your message, the transmitter would immediately send on the same pulse and start sending the next character. The 5 is at the end of your message, the transmitter would just stop, the receiver would sit there waiting for you to send another character, which would be a sync pulse. The time between each character is unimportant. Here we have a little flow chart of how each of the programs work. Over here on the transmitting side, once you start it, it's just sitting there waiting for you to type a message in. Once you've done that, it converts that message into 7-bit binary packets. Once it's done that, it initiates a timer interrupt trigger and sends the signals, starts sending each character in the binary code. And then once it's finished with all that, it's done. Now over here on the receiving side, once you start it, it's sitting there waiting for the sync pulse that this sends whenever it's about to send a character. Once it's received the sync pulse, it indicates a timer interrupt trigger on this side and starts looking for the next 7 binary pulses that this is sending. Once it's received them, then it turns off its interrupt trigger, and the program on the Arduino converts that into an ASCII character, prints it out, and starts waiting for other sync pulse for the next character. Right here we have an extremely high quality video of this in action. I will play this again, so don't worry if you miss anything. Yes? No? No? It's not working.
Hit the space bar. No.
This is convenient.
No, it worked when you practiced it this afternoon.
Give me 1 second. Let me try and get this working before my time's up.
I'll give you an extra minute since you for technical difficulties. You just open it out.
Yeah.
Can you open the file separately outside the slideshow? Yeah, just open the video file.
So right click it maybe?
All
There
right.
it goes.
Ah, there we go.
I'll just drag this over. We'll just give this a second to finish up. This is the receiver actually receiving the message and printing it out. Okay, so right here, as you can see, the message that we've typed in is AAPT New Orleans 2016 Hello World. And although you can't really read it, right here it is printing out each character and showing you that, what it has, and then displaying the binary code next to it of what it is sending. This is it actually blinking through the tube, and the reason you can see that is because the light likes to travel in the vinyl tube more than the mineral oil, which is, again, not ideal. And then here you can see the receiver actually receiving the message as it is getting it linked through the tube. And then here is a website that you can go to if you want to download the full description and all of the software and code that we use. And I'll leave that up there, and that's really it.
I have a question. Is this your first talk at a professional meeting?
Yeah.
How many of you have 11th graders that have given a talk at a professional meeting in front of them? Anybody? One person, two people? So yeah, you're in a small group. So we have time for one question.
Have you considered putting your transmitter and receiver on the transmit and receive pins of two different Arduinos and just tell it to communicate with the built-in serial hardware on the Arduino?
I suppose we could do that, but this is the kind of thing that, you know, our class just decided, you know, why not just try to do that? I mean, both yourself and the second speaker, I can't see back there, I think, but you know, you talking about how your Arduino is a great tool for teaching, and that's, I suppose this is the perfect example to show it.
Well, I mean, you still do it with the same light setup. Just hook it up with the serial port on the serial pins on the Arduino. I just wondered, the reason I was asking, I was wondering how fast you could go with this. It looked like you're doing about 1 baud at the moment.
If I remember correctly, I mean, I filmed that little video a while ago, but I think we slowed it down a little bit. I can't remember exactly, but we had it stably going a little bit faster than that, and I remember that we could get it going about double of what was faster than that, but it was kind of unstable and it working correctly.
Okay, let's thank our speaker one more time.